In this lecture, we're going to take a look at how we can create our own classes and objects.
We're now going to take a look at object-oriented design. So what is that? Well, what we're going to do is we're going to take a look at our problem and we're going to identify different components that we can classify into either classes or objects. Well, that's great and all, but what are classes and objects? An object of a class has both data and operations that we can perform on that data. So the whole point is we're looking at some part of a program and we can think of an object as this component that has some information about it, some attributes, some data, and then there's some actions or operations that we can perform on that thing. Now, a class is just the Java structure that lets us combine the data and operations into this single unit. So we're taking the attributes and we're taking the operations and we're putting it together in something that we can write code about. So this whole process of combining our data and our operations is what we call encapsulation. And this is the first key principle of object-oriented design. So let's take a look at the string class as an example. So we have several methods that we can use on strings, such as concatenation, comparing, and so forth. And we can create objects of the string class, and we can invoke methods on those objects. So class is a very convenient way to let us group up our data and our objects together. So here's an example of the actual string class. Now this is only a portion of it, but at least gives you an idea of what the class looks like. So the whole thing is encapsulated in this class that we call string, so that's given by the name here. And we have all of our variables that would be stored in this area. So we just put a comment there to say, any variables that we have there pertaining to strings would be at that spot. And then we just have these different methods. So we have compare to, concat, to lowercase, and we would have all sorts of other string methods as well in here. We're just using these as an example, but we would just have the definitions of all the methods that we can perform on any object of the string class. Now, what if we want to design our own class? Well, we're going to need to know the data that we're going to manipulate, and we need to know the operations that we can perform on that data. So let's take a look at an example. So let's say we want to design a circle class. And this class would just implement the basic properties of a circle. So we need to ask ourselves, what are some of the relevant data that we would need on this class? Well, every circle does have a radius, so we can make that an attribute of the class. And then what kind of operations can we perform on a circle? So the two basic operations that we can think of are finding the area and the circumference. So we can make those methods of our class. So here's the class that we just talked about. So we start by having public class circle. So this line right here will give us the declaration of our class. We have our attribute, our radius right here defined as a double. And then we have our two different methods. We have our area and we have our circumference. Now we didn't put the full definitions in here, but this would be the structure of our class. Formally speaking, a class is simply a collection of some number of components. And each component is called a member of the class. Here's the official syntax. We've seen some examples already, but here's the syntax of our actual class. So we'll have some set of modifiers, the keyword class, the name of the class, and then possibly some modifiers afterwards, pair of curly braces, and then any number of class members we want inside the class. Now the modifiers just simply alter the behavior of the class, just as they alter the behavior of methods. So for example, we can include keywords such as public, static, private, and so forth. The class members themselves can have be named constants, they can be variable declarations, they can be methods, they can be even other classes. So the way we use variables and methods inside the class are no different than in any program. So we can declare variables, we can define methods just as we've done in previous programs. And of course, any method that's in the class can directly access any member of the class itself. So if I declare a variable inside this class, and then I declare a couple of methods, all of those methods can use that same variable that we have declared. The members of a class are classified into 4 different categories. So we have private, which just means that we can't use the member outside of the class. So I could still use it inside the class however I want, but no other program, file, class outside of the current class is allowed to use it. There's public, which means that we can use the member outside of the class, so any other class is allowed to access that particular member. We have protected, which means that the member is private, so no external class can access any of the protected members, but it can still be used in what we call subclass. Now we won't get into it a lot of details in this course, but the idea with this is we can have classes inside of classes, but even those classes are not allowed to access private members. So we can use protected to access those members. Honestly, we won't be using protected that much, if at all, in this course. And then there's the no modifier. We could just simply not include one, which means that the member can be used anywhere. It can be used within the class, it can be used outside the class, it can be used however people want. And this particular option should be avoided at all costs because there's some huge security issues by just freely letting members being accessed by whoever wants to. To help explain classes, we're going to use a recurring example, and in this case, we're going to be using a clock class. So we're going to let our time be represented as a set of 3 different integers, the hours, the minutes, and the seconds. We can also perform several operations on the clock itself. So we could set the time, we could return the actual hours, we can return the minutes, we can return the seconds, we can print the time on the screen, we can increment the time by 1 hour, we can increment the time by a minute, or we can even increment the time by a second. So each of these operations that we can perform, we're going to make them as separate methods in the class. So we had 8 different operations, so our class is going to have 8 different methods. Now as for the variables, we're going to set them to private. And this way we can't directly access the variables from other Java classes. This is actually the norm, that when you're creating a class, most of the time, like I would say 99 times out of 100, you're going to make your variables private. And we're going to let the methods take care of getting the values of the variables. Just once again, the whole purpose is we want to make sure we have control over what values are stored in those variables. And if we allow direct access to those variables, we could have some issues. So we normally set them to be private. The methods are usually set to public. That way we can indirectly access our variables. We can indirectly modify them, and it allows us to decide what kind of ranges that we want to help with this. And we'll see some more examples to show why making your variables private and making your methods public are very useful. And then variables that are not declared as static will be called instance variables. And for our purposes here, none of our variables are going to be static, so they are going to be instance variables. So we'll now take a look at the actual variable and method declarations for our class. So we'll have a private int hour, private int min, and private int sec. So these would be the variables of our class. They'll represent the hour, the minute, and the second. And then we'll have a method called setTime, which it'll set the time. So we'll take hours, minutes, and seconds as parameters. We'll make changes to hour, minute, and sec, and then our time will be changed. And then we can have a couple of methods for getting the values of hour, min, and sec. So that would be get hours, get minutes, and get seconds. So they just simply return the hours, minutes, and seconds of our current time. We can print the time, and here the format will be 2 digits for the hour, a colon, 2 digits for the minute, a colon, and 2 digits for the seconds. And then we can have methods for incrementing the hours, minutes, and seconds. So we have increment hours, increment minutes, and increment seconds. So these will increment the time by 1 hour, 1 minute, and 1 second respectively. Now our class methods can actually be broken up into 2 different types as well, what we call accessors and mutators. So any method that actually changes the value of one or more of our instance variables is called a mutator. So using our clock class as an example, set time would be a mutator because it changes the value of hour, minute, and second. And then any method that retrieves the value or accesses the value of a variable and it doesn't do any changes at all is called an accessor. So in this example, getHours would be a method that returns the value of hour, but it doesn't actually change the value. So remember, accessors are methods that allow us to get the value of an instance variable without making any changes to it. Mutators are methods that actually have us change the value of those variables.